All right. So then I would say, without any further ado, we hand over to the first speaker. So I want to welcome Doug Turnbull on stage. Okay, round of applause. Okay, so I don't know whether Doug needs introduction. So I know him from the time at OC, where he was CTO. At the time, he wrote the book Relevant Search, which has, I think, inspired a lot of people in the room to work at Search Relevance. Then he joined Shopify, so that's his connection with e-commerce, and also co-author of AI-powered search. And today he will be speaking about planning e-commerce search relevance work. Welcome, Doug.
Thank you. Thank you. So yes, I did join Shopify, but I do work at Reddit now. It's just that's okay. I just want to make sure I like presenting myself accordingly. Yeah, I think I already had an introduction. I'm Software Doug everywhere, so if you want to find me, find me. I think it's better if you just find the flyer over there. I think we talked about this just for the sake of time. But yeah, it's really exciting. I wrote a lot of the learning to rank content in particular. And Trey and I are around if you want to chat about the book. So I'm going to talk about planning search relevance experiments. And a lot of this is inspired by work at Shopify, and a lot of it's also inspired by work at Reddit, just how I think about and we think about planning things. And I'll talk more about this, but really, I really believe in the collaborative spirit of doing search well. Like I've never seen search be done well where everyone is in their silo and not talking to each other. So this talk is especially, I think, if you're a data scientist or an engineer, or you're trying to work together across those boundaries, like plan things, but also build things, that's really important. And obviously PMs care about planning things and making sure we invest our time wisely. So what do we currently do when we're planning? This is my life at Reddit. It's about every quarter. At Shopify, we did 6-week cycles. We'd more or less just come up with, I mean, I'll be honest, a lot of just ideas that people have, and they sort of throw them out the wall and they hope they work out. Sometimes there's a little bit of evidence behind them, sometimes not. Sometimes there's pressure to build certain things. Sometimes you have ideas that people come up with on their own, or they read a cool paper. And often your gut, mostly your gut, I would say 90% gut operated is the planning process. We pick something, right? And that's what we're going to do this quarter. And how many people have done this? You spend months building something and then you launch A/B tests and it doesn't work. This is life, right? We're kind of pulling ideas out of the hat, sticking it in, and we realize we are not doing well. And we get stuck, this psychologically, you may have heard this term sunk cost trap. I also really like the term feedback debt, which is basically you just keep digging. And even after this like failure, you say, oh, I can analyze this. What went wrong? Let me try it again. Let me try it again. And you sort of like go so deep in one direction, you lose the plot a little bit. You lose the forest by focusing just on one tree. And this comes with massive opportunity cost, right? You can't go and this person over here found something cool. No, they have to keep digging. We promised AI whatever solution. We have to keep digging and making it work, right? And this has been, I would say, opportunity cost, sunk cost trap. Feedback debt specifically is just building without getting any feedback is a pretty consistent problem across every search team I've ever worked on. And it's not easy, and I don't propose that I have like the silver bullet, but I maybe have some things that have worked. So some usual solutions that I've seen, you've probably seen like simple correlation studies. Someone goes to SQL BigQuery and says, it seems like people click more when there are more stronger title matches. Why is that? I wonder why that could be. And then you realize, oh wait, correlation is not causation. What's causing that is because we're surfacing things with more title matches. So it's hard to even study what even to add to our relevance and our ranking to make an improvement. So there's also gap analysis. It's a pretty typical strategy people do. And by gap analysis, we sort of look at our queries. We see these, maybe this is sorted on click-through rate or add to cart. We see, oh, shoes, running shoes. What's up with these queries? Why are they not performing well? And maybe that's a place to target like a relevance experiment. And the problem with a lot of times, and we had this problem actually, we spent several weeks at Reddit because our top level metric was very coarse and very difficult to move, even at the entire experiment grain. Like it'd make like a good experiment be like a tiny movement in this metric. So when you slice and dice things down to something like a query, you're going to get like just entirely just noise, right? So why iPad is performing better than shoes could, over the life of an experiment, could entirely be noise related. So that's something really important to keep in mind. And Andreas had a really good talk at Berlin Buzzwords about, analyzing A/B tests. And this was one of the main points, is how these high level metrics can be really hard to split up at the query grain. Of course, most people know that, how we might traditionally do evaluation is we might come up with an offline judgment list. So we might use clicks, we might have human labelers, we might have LLMs these days. Something happens in this gray bubble. And by something, I probably mean like months of data science investment and constant iteration, but that's a whole other talk, and we'll get some talks on that. And I've given talks, Renee's given talks. There's chapters in AI-powered search. There's entire books written about that cloud. But we do get something back. Maybe we get a relevance grade, a relevance of a product for a query. So we have a query, a product ID, and a relevance label. And we can use this for statistics that I'm sure you know about, like DCG and DCG, that basically say, how much are we moving the good stuff above the bad stuff? These are classic, search evaluation metrics. And we might try to put a number on the left-hand side one, or my right, your left-hand side, to say, oh, we need to figure out why this one's better than this one. Let's give this one a higher score because we sum the grades and we get an average over all the positions, or we compute DCG or something, right? So this is something else that can help us, right? When we're doing planning, this is a great tool. And maybe if we trust this data and we trust that at the query level, and here it's even trickier because you're splitting at the query product level. But maybe we can make some assessments on, like, do some better gap analysis. So what do we often do as teams? And this is the current process that people often do. What I have often seen is some teams will go all the way to building. They'll have all the systems in place. They'll build their indexing pipeline out. They'll have their query understanding layer. And then finally, at the very end of months, more or less right before the A/B test, they run their full test suite in production, and they get sort of a thumbs up, thumbs down, or they get sort of like a go, no go, or they realize at that point that then they may have wasted months of work because it doesn't work at all, right? And then maybe we release it to A/B test or not. Much better, of course. And this starts to push us back in time to the beginning. We're sort of like earlier, we started maybe after an A/B test analyzing, and we're now going earlier and earlier to points in time in the process. Maybe we could test earlier in the process. Maybe we could make that first initial change, see if there's signal, and iterate and constantly improve. A bit more ideal. This is sort of a smarter way of doing it. We're just constantly tuning. But we actually want something a little bit different than this. We can't be, preferably we would get some signal before we invest months and months of time, right? That would be the ideal. So how do we do that? Or what would we like? We would prefer to ask ourselves, like, how could we can we justify a change before planning? Can we sort of get a vague sense, maybe a quick check of the outcomes? Could we maybe build our solution in easy mode and sort of prototype mode before we go whole hog? And then that can help us manage stakeholder expectations. That would be ideal. We could say, this is maybe an incremental change. It's going to be affecting recall, or it's going to be affecting precision. It's going to be maybe something that changes diversity. And we see maybe you can't match it to a improvement in add to cart or something, but maybe you can say it's in relative terms, it's a smaller or bigger impact kind of change. And we would want to try all the things, right? We don't want to do what I showed before was very much a depth first search. We pick an issue, we spend months and months on it, we ship it, we get it, do an A/B test, and it works or it doesn't work. Preferably, I think it's very important to get in our team's cultures to do more of a breadth first. So we try lots of ideas, and some of them don't make it past the stage. But we have some data behind this. We do shallower testing. All these people are digging their own little holes, and they're trying lots of different things. Yeah, and people just, the other thing I'll say is, I've seen a lot of search teams. You get search is often a place where solutions come looking for problems. So you get the team, building a taxonomy over here, the team doing this fancy thing over there. Oh, you should really try this on search. And the dynamic that ends up happening is sometimes a negative one, where you say, get out of my hair. I'm working on my own thing over here. And it's also like something you also don't want as a search team, just like some ML model dropped in your lap that then they go off and do something else. And then you're maintaining this thing, you have no idea how it works. That's a pretty crappy dynamic. And so often I think, like, if you could find a way for them to self-service and try out their ideas in the context of search to prove them to you that they're worth investing in, that can start a partnership and sort of take an enablement posture, as opposed to kind of a, oh, stay out of my hair, kind of posture that we often find ourselves in. Maybe someone who doesn't know search, but knows some data science or machine learning could maybe get involved. That's often a challenge. Or maybe just someone from, a content team that wants to change some content. If we get all these people trying lots of different ideas, the more we can go in this direction, the better. And I think it's really important not to, we tend to get so obsessed with, and I've been this person, right? Renee and I have a lot of conversations about, like, oh, how could we understand clicks and engagement to make the perfect labeled judgment list and all these things. And I realize after years of having this conversation, maybe it's not worth it. Like, unless, obviously if we're training a machine learning model and all these things, that's really important. It's training data. But maybe if I'm just wanting to get a quick signal on something, maybe we're overthinking that. Maybe we just want to get an initial sense, a gut check on an idea, see if it's easy, see if it's, something we might pursue or just not worth pursuing at all. So something that we want shallow, fast feedback that we can try sort of our ideas in easy mode in 4 hours and not 4 weeks. The quicker we can do that, the better. But there's a problem. The problem is, this is our search system. That's our engineer describing how the search system works, right? And if you are maybe focused more on the data side, doing machine learning, or like you're used to, your world is like Jupyter notebooks and NumPy and pandas and maybe TensorFlow or something, you come to the search stack and you're like, Solar's here, I got Pinecone, I got this API that calls out this thing, and then there's this whole indexing pipeline that sometimes we have a whole indexing team that keeps the index up to date, all these things. And it's like, where do I fit in my like little tweak I want to make to like prioritize products that are popular in SEO or something like this. That's a nightmare, right? That's where we, I'm a data scientist. Your Kubernetes frightens me, and this is often the position I'm at. I'm like, oh, how much Kubernetes do I have to learn? So this is how all these holes get deeper and deeper. This is where our sunk cost trap comes in. We get very deep into investing because I just spent a month understanding how the search API works, so I could change 3 lines of code. I'm not going to give up on that idea. Like, I'm going to keep going. So it takes a lot of time to, it's a big project to try anything out. So we're stuck in a paradox. This is the crux of life, I think, on any search team. You can't do anything without planning. Like, you can't do anything without planning and maybe getting some numbers, but you really can't plan without building something, right? And then like somehow getting a measurement of how it works. And I don't think you can fully overcome this paradox, but maybe there's some things we can do to mitigate it. The first thing I think that's important to keep in mind is that this is all just math, right? All of this infrastructure and everything, we get stressed out because it's very like, oh, there's like it's very complicated libraries and if statements and things that happen. At the end of the day, we're ranking results and we're showing them to a user, and there's some kind of math that puts all this together that makes this happen. So if we can get the ranking function out, and this is sort of like we talk about a ranking function, and I'll talk about mostly in the context of ranking, like we're sorting things by score, but there's no reason this doesn't apply to thinking about other problems in search like diversity or whatnot. But we have a ranking function. We have a set of features, right? Maybe some BM25 score on some field. Maybe we have something else that is actually some post-processing in our search API. If it mentions electronics 1, otherwise 0. Dimension 121 of some query embedding, right? All of these things go into our model. So the most important thing that you can do to really plan better is to find a way to unbury your ranking function from your infrastructure so that it's easy to play with and iterate on. And there's lots of ways to do that. So like, obviously, there's different components that come into our ranking function. How you query Elasticsearch. There could be some query templates you have somewhere, or how queries are put together. Maybe there's some complicated function in your API, lookup in a vector. We've got to figure out a way and this is the message to the software engineers. It's not just about building infrastructure so that it's, testable and sort of like stable. You're also building infrastructure so that it's experimentable. It's something you can prototype easily. And think about that, we're used to decomposing things for unit tests. Think about decomposing things for offline experiments and prototyping and giving people like a Kaggle-like experience where they can play with things. Ideally, we could take our, maybe I put this on LinkedIn before, but golded. Everyone has golded, right? Past tense of gold. So golded, we have our golden queries, right? We often have a golden query set that's labels. We could downsample that into a golden corpus. We just get every labeled and positive and negative result. Just have something to play with. It doesn't have to be, this big fancy thing, sampling procedure. Just get a sample, get yourself into like sort of Kaggle mode so that you can play with these ideas in easy mode. If your idea can't pass easy mode, it's not going to do well in hard mode. Then we can sort of create a baseline of this. And then we can, in a Colab notebook or something, we can use tools to recreate some of the search index stuff. I worked on a tool called Search Array that kind of recreates BM25 ranking in pandas. And then with your golden corpus judgments and whatever, you can play in a Colab notebook or something. And just sort of get the experience out of your, get your ranking out of your API and get them into something you can experiment with. So just as a quick example, I've got the WANS data set. So WANS is a data set that is from Wayfair that they've opened up. It's a search data set. I won't go too deep into this, but what I've done, and this is actually interesting. So I've got a lot of I've pulled down this data and I've been able to index it just locally. I've got a little downsample here. I'm just getting everything, every query, every labeled product for a query, any query in my query set. I'm going to index that locally. I've got some local sort of tokenizers and things. These are things that usually you have some complicated Solr Elasticsearch configuration for, but we can play with these things in just pure Python code if we want to. We can index them into a pandas data frame, and we can just try different ways of searching. We could say, okay, I'm going to issue some basic searches. I'm going to sum for each of these terms, for every term that I tokenize, I'm going to sum them. All these things are things that are hidden behind fancy query parsers in your Solr, Elasticsearch, OpenSearch, whatever. I can get a score for them and I can just see what the search results look like by just running a pandas data frame. So if you're familiar with data science, you can sort of see how that works. I can do all kinds of things. I'll let you, I won't get too deep into this because I don't have the time. I could try things like, I could just create a baseline search that's going to iterate every term, snowball tokenized, and maybe pick the maximum, the best term match in each field, and then sort the corpus for each document based on that and get a top end results. But the point is like not to recreate your entire search ranking in a Colab notebook, but just to get a few things in here to then add your thing and just see what it does. Just play with an idea and see what it does. So you can say, oh, look what happens when I use this LLM generated text for describing my products. It seems to help things, or it doesn't seem to help things, or here's the problems I found with it. You're trying things out in easy mode in small data, like everyone talks about big data, but small data is the most powerful way to actually have a conversation on your team with product managers about an idea. And then the other thing you can do that's really easy is we can just experiment with what happens when we add a new feature. So people talk about machine learning models and these sorts of things. Some tool of machine learning models is just as a means of analysis. So if I can add a new feature, there's two questions I want to ask. Does it add information to something that's already on top of what's already present? And is the information something that helps me distinguish relevant from irrelevant documents? So these are two really straightforward questions. Adding new information is, I'll just show this really quickly. And if I don't get to, let me just go to one of these tabs. So I can sort of fall through the same process I went through before. I can get this data set, I can index some things. And what I can do is for everything that I have a label for in my judgments, I can extract a feature, which a feature is just a different way of scoring. Here we have an OR query. If the product is salon chair, this is just salon or chair in white space tokenized, maybe snowball tokenized, and so forth. I can just get scores for all of these things in a set of features that are just going to be numerical values of how these things match up. I can gather that for all of my queries. And here you can see just I'm focusing on the feature that's really 1 or 0. Does the name match any terms in the query? Here you see salon chair matches chair, rack glass matches glass. Pictures to hang over fireplace doesn't match anything here. So this is just a 1-0 feature. But I can have lots of features. I can have all of these features that are just sort of like, and this is actually normalized plus or minus the standard deviation now. But you can see the BM25 scores of these different things normalized. And you can see that the, what the this whole sort of like what features might go with maybe relevant or irrelevant documents. But statistically, we can actually do what's called a sort of look at this pairwise. So all this means is we look at every query's relevant document, and we might subtract an irrelevant document. And what we see is what features tend to go with that swap? What features tend to go with correlate with the pairwise different relevant and irrelevant documents? So if we do that, we get this matrix that says like, here is, the feature for each of these compared to the feature for another one. And actually, this is just the delta now. Underscore X is the delta of each of these features. And then we can ask ourselves, what features tend to correlate with each other? And this is where we get to whether or not something adds new information. And this is something we do at Reddit, actually, for learning to rank, for building models. You can see, of course, that like each feature correlates perfectly with itself. But these other features, like this one over here, description snowball BM25 ads actually is not super correlated with the name whitespace tokenized BM25. So if we do this, we can also just like summarize just by summing over this correlation, which of these adds the most information. The name whitespace seems to add the most information compared to the other ones. That correlates least with the other features. And finally, if we actually try to classify the relevant from irrelevant pairs, we can see sort of like, okay, what is our current sort of area of the curve? We can see like how good are we at classifying relevant versus irrelevant. So just to close, if we try, let's say, what we would want to do in practice is to maybe add a new feature. Let's say we do phrase search, which I have up here somewhere. We might say, okay, what if I add a phrase search feature? We're gonna search name and description with phrases and what happens with that? Well, if we look at our correlation matrix. How much is this adding information? It seems to not be super correlated, honestly, with these other features, except obviously it's correlated with itself. So it's adding information. But then second, does it add value? And you can even see here, this one is like least correlated with any of the other ones. And does it add value? Well, if we go over here, we can see the ratio of true positives, the sort of precision of this, is actually a bit higher than what we had before. So then we could say, well, maybe this is a direction we should pursue with our planning. If we could just get our data into easy mode and just play with ideas, then we could actually plan this stuff better. And I won't have time to get into it, but there is also, feel free to come up to me a bit later, but there is maybe some thoughts of if you want some thoughts on how to make your code more prototypable or to make your data a bit more easily able to downsample, feel free to come up and chat with me about that. So that's it.